Hey everyone, thank you for joining. We're going to give it a few minutes just to see if if more participants will join, and we'll get it kicked off. Thanks everyone who's already joined. We're just going to give it a few minutes here to see if a few more people might trickle in. All righty, I think we've got a quorum here. Thank you everyone for joining. Today we're going to walk through the Sumo Logic observability solution and give you a quick walkthrough of what that solution has to offer here at Sumo. For the story here, we're going to pretend like I'm an SRE. I'm a site reliability engineer managing an application. This application consists of a payment service that talks to a account service that runs on top of Kubernetes. And we're dealing with a account service that has to rely on a flaky database. In that type of stack structure, I receive an alert late at night that says my payment service SLO is having a violation, that it's seeing a higher number of errors than I expect. And so I go ahead and click on this playbook dashboard and I jump right into Sumo Logic. Sumo Logic is centered around the error itself. So I can see here very quickly the signal outliers. So I can start to see when the signal deviates from its standard deviation norm. So we can see a huge spike right here. We can get a quick view of the max error rate in the time period, as well as the customers impacted. So if I scroll down here, I can see in this panel that we have Aero Electronics, SentrySafe, Comet Airlines, and a bunch of other customers who have been impacted by this outage. We can also very quickly see the ARRs, their locations. This can be very helpful as we're trying to solve this problem, as information in terms of who's being impacted that we can share with our customer support team, make sure that they're able to handle these customers if there's any issues that we need to be aware of there. Similarly, we can correlate the outage itself with business level KPIs, such as transaction volume and dollars transferred. We can see that our business has taken quite an impact from this spike in error rates. So hopefully we're able to recover this problem quickly. In order to start actually diving in and understanding how to break this problem down and figuring out where this problem might be coming from, we can actually break down that error signal by the actual pods that are running the application rather than looking at it from an aggregate standpoint. So each honeycomb here represents a pod in our Kubernetes system that's running the payment service application. The green ones are the pods that are behaving pretty well, and in some sense, their error rates are not that high. The yellow ones are seeing higher error rates, and the red ones, of course, are the ones with the highest error rates that might be contributing to the elevated error rate we're seeing up top. We can actually click on the honeycomb to follow the signal through and through, pull up some more details about the honeycomb itself, and jump into the infrastructure tab to actually get the entity information behind the data point. So this honeycomb represents a pod that has a container inside of it called payment service that sits within some deployment, that sits within a namespace, that sits within a node, has an associated service, and sits within a cluster. By having all these key KPIs and objects right here, we're able to very quickly get a scope and understanding of the context behind this pod with regards to that Kubernetes cluster. We can tell you information like, okay, is the container behaving correctly at a glance just by looking at the KPIs? Similarly, we can judge if it's a node problem by looking at the node KPIs and realizing whether the CPU memory or the ready state might be affecting the performance of this pod itself. And of course, if we ever want to dive in to get more details, we've got these quick open in links that allow us to pivot, whether it be on entities, log searches, traces, or metrics. Given that we're seeing a bunch of red pods across this deployment, it seems like we want to actually dive in at one level higher than the pod itself. So let's go ahead and click this open in for the deployment, select the entity dashboard. We can actually dive into the out-of-the-box content available to go understand this deployment in Kubernetes. Here, what we can see is we see some standard statistics about pods running, total number of pods, whether they're in a running state or not. Over here on the right, we can actually see that there's a bunch of connection errors happening with this payment service. And in this table over here, we can see that the payment service is struggling to talk to this account service. And it seems like we're getting a bunch of connection refused. Once again, we can follow the red data point through and through, click on the data point, jump into the infrastructure tab, and look at the account service deployment and pivot into traces to actually understand that connection itself. When two services are talking to each other, it's important to understand the transactions going on between those services to understand where that error might be coming from and which portion of that span might be causing the problem. Driving to the trace list, we can actually see all the traces that are happening between these two services. We can see if the root service is the payment service, and we can see that it has a portion of talking to the account service as well. We can go ahead and select this trace to go and identify and dive into the spans themselves. Looking at the spans, we can see that there's a payment transact call that talks to a payment service.transact that makes a get call to an account service that has an account/name endpoint, which hits an accounts.getAccount, which eventually ends up with this CRUD repository.findById. So this is the last span in the trace that we have, and it's the one that's erroring out. Let's go ahead and pivot to the logs underneath that trace span to better understand where that error might be coming from. Here we can dive in based off of span ID or trace ID if those are already tagged. We can also jump over into the infrastructure tab once again to pivot around the entity and use the entity information to guide how we pull up the different streams. This time, let's open it up in the log search, drive right into the logs, and see what log streams might be underneath this specific trace and this specific span. We've now narrowed it down to the specific object for that specific time period of the span itself, giving us a very, very tiny refined range to go look at. And you can see we still have 3,300 messages. That's a lot of messages to manually parse. That's where with Sumo, you can press log reduce, and that'll compile down those 3,000 messages into 14 to 15 signatures that we can very, very quickly glance through and understand. Here, what we can see is that there's some connection not available and timeouts happening. And if we scroll further down in this list, we can see that there's around 360 too many connection messages coming from a SQL non-transient connection exception, where it's saying it's failing to talk to a database. Once again, this is the account service that's failing to talk to the database that we have. That's likely driving the error rate that we saw with the payment service, the connection refused that we saw with the payment service, and the error rate that we're seeing on the top level SLO. As an on-call engineer, I can quickly now increase the capacity of the RDS database, give it more connections for now to handle the higher increased load, enable the recovery of the actual top level SLO, the recovery of the connection refused errors coming through the account service, and actually enable myself to go back to sleep, see my business metrics recover, and then dive in deeper to find the root cause tomorrow or the day after. This enables me to find that remedial cause very, very quickly without having to write queries, and all revolving around the concept of an entity and how it allows you to stitch together logs, metrics, and traces. To quickly recap before we go into the root cause, we can see here that we started with the top level database, top level dashboard that walked us through some top level KPI. We broke that down by the actual pods themselves, used the pods to drill in via the entity into the deployment. From the deployment, we were able to find the connection refused errors and use that as a pivot into traces. Diving into a specific trace, we were able to see the span breakdowns. And following the errors through the spans, we were able to find the right span to drill into, which led us to the logs. And from the logs, we used log reduce to collapse it down to signatures, which gave us a remedial root cause that we were able to use to solve this problem in the short term. Once you found the short-term remedial root cause, oftentimes it's important to actually go do some analysis to find the real root cause and understand the patterns of behavior that are being experienced by that RDS database. We've got a feature called Root Cause Explorer, which can help us identify anomalous behavior that's happening across our infrastructure. In this case, let's go ahead and zoom out and see what's happening to that RDS database. We can go ahead and add some filters for RDS anomalies and center our world around that. Here we can see that we're seeing an increased level of write IOPS, as well as an increased amount of load. 256% anomalous load happened around this time. Clicking on this RDS load anomaly, we can dive in and get more details about the anomaly itself. from metadata about where it's happening, what type of drift it's having, to the metric itself and how it's spiked. Hopping back into infrastructure, we can actually get further links, whether it be recommended dashboards or related logs about the database itself. Diving into the logs, we can get more information about what was happening to that database at that point in time. And here we can see that there's a bunch of slow query logs suggesting that this database is executing very, very heavy queries that might be chewing up connections, chewing up CPU and memory, and preventing us from being more efficient with how we're using the connections coming in. Now I can take this information back to the dev teams, let them know that these database queries are too slow, ask them to optimize it, and hopefully reduce the requirement to actually up the amount of memory and CPU that my RDS database has. Now we've been able to find the true root cause and actually improve the efficiency of our application. So what we've been able to do with Root Cause Explorer is we've been able to go from the actual anomalies themselves, narrow it down, and use that as a pivot into the actual log stream to go understand and introspect what's happening to that specific object. Through the entire process, we've been able to go from a top-level dashboard all the way through and through the variety of different data streams to actually figure out what the remedial and root causes are. Let's see if there's any questions. Are there any questions I can help answer from the folks that are attending? Perfect. If there's no questions, thank you for attending. That's kind of the workflow here for the End Observability webinar here at Sumo. Please give it a shot with the Sumo trial link that's been posted in the chat, and we look forward to talking to you again.